Hey there guys, it's Todd here. So today I will be explaining the concept of the range. So I went out for a meal the other night and I took my family, and after I had paid for the meal and everything, I got the receipt and I kept it. And I've taken all the items which I bought off the receipt and I've lined them up back to back here. So I had a steak, then there was some pasta, then there was some garlic bread, and there was another steak, and there were some other things which we had at dinner. So these were the prices right here. And I'm going to use these prices to explain the concept of the range. Now, the range is a measure of spread. So it's a measure of spread. And what that means is that it tells us basically how spread out our data is. And we can usually describe our range in one of two forms. So we can have a narrow range, which I'll do in red. And a narrow range means there was not a lot of variation in our observations. A variation. Or we could describe our range as wide. And this means we had a lot of variation in data. So what we're very concerned with in further maths is calculating the range from a variety of graphical displays. But it's important to know how to calculate the range just from a set of numbers before we can do this. So I think it would be handy if we just took all these prices which I've saved. So we took these prices of steaks, pasta, garlic, steak, and we work out what the range of prices was for the meal. So if we think about it logically, the range of prices, we want to know what possible values our prices could have taken on and what were between, say, our minimum and maximum observations. So what range of prices did I pay for my food? And the way we would define this is we would come back to this nice little definition of a range. So the range is equal to the maximum value of x, which I'll denote as maximum brackets x, minus the minimum value of x, which I'll denote as this minimum x. So what we need to do to find this maximum minimum is we just need to go to our data and we need to basically find which is the maximum and which is the minimum. I'll do this minimum in another color. I'll do it in minimum x. So if we go to our data and we want to find our maximum value, so we're looking through, we can see that it was a steak because we have $25.50, $19.50, $11.50, $30.50, $20 and $19. So it's going to be our steak, which costs us the most, and we'd expect that. Usually when we go out, steaks cost the most. So up here, our $30.50 is going to be the maximum value of x, which is that. Now we want to go through and we want to find our minimum value. So if we count through, you can see that it's not going to be $25.50, it's not going to be $19.50, it's not going to be $20, it's not going to be $19, but it will be $11.50, which was the garlic bread. So that's our entree, and we'd expect that to be the least costly. So going to take away our minimum, which was this $11.50. So if we just do this equation, this will give us the range of our data. So if we solve that out, we have $30.50 minus $11.50, and that is just equal to $19. So we're able to say that our range was equal to $19. And if we think about this logically, it means our prices took on values, had a maximum possible number of values of $19 above $11.50, which gives us this range calculation. So there were 19 possible single dollar values which could have been obtained in between our $11.50 and $30.50. As I say, these questions are usually applied to graphs, but what we can do is calculate our range just from a set of data, and it's quite an important and handy skill to know. Thanks for that, guys, and have a look at the examples for this.